Hello everyone, this video is about logarithm formula derivation. The exponential function is in this form: a times b to the power of x plus c, so we have b to the power of x. The b must be positive and it cannot be 1, and the x can be anything. Now, in case you are wondering why must the b be positive, so let's just try this exponential function simple 2 to the power of x. If we plug in x equals 0, we get 2 to the power of 0, which is 1, x to the power of 0.5, that is square root of 2, which is this in 3SF. If the x is 1, we get 2, and so on. So as you can see, we have, as the x is increasing, the y value, the 2 to the power of x, is also increasing exponentially, smoothly. And if the base is now something negative, for example, minus 2, when we plug in x equals 0, we get minus 2 to the power of 0, which is 1. But when we plug in 0.5, we will get an error. If we plug in 1, we get minus 2. Plug in 1.5, we get an error, and so on. So this means if the base is something negative, it does not work all the time, because we get error, error, error. Actually, we will get error most of the times, because we can also try and plug in 0.1, 0.2, 0.3, and we will always get an error. So this means if we use negative base, we can only use integer x. So like 0, 1, 2, 3, or minus 1, minus 2, minus 3. And if you look at the pattern, it's like from 1 to minus 2 to 4, so it's like not in an obvious pattern, zigzagging plus minus plus minus. So we call this discrete. It is not continuous like in this positive base case. So that is why we don't use negative base. And we don't use 1, of course, because if it's 1 to the power of something, it's always 1. So 1 to the power of whatever is just 1, so it's just ridiculous, because we have a horizontal straight line y equals 1. And for a logarithmic function, this is the form. So we have log base something. The base must be positive and it cannot be 1. And in case you are 1, and also the argument cannot be a negative or 0. So the argument must be positive also. So why b is bigger than 0? Well, let's just try. If the b is 2, we plug in, you get this. Again, it is smooth, and you can plug in whatever value of x here, as long as it's positive, of course. But if the base is minus 2, this is not possible, not possible, not possible. So again, we can only use this logarithm only for certain values of x, and this means the logarithm concept will be useless, because it's only useful for certain values only. But if the base is positive, we can use it not only for 1 and 2, actually for 1.1, 1.3, 1.123, we can use it for anything, for example like 9.5. So we can say it's continuous and it is smooth for any number positive. You can use the logarithm concept. So again, we don't use this because this will make the logarithm useless. Now to understand the Euler's number, let's just derive the compound interest formula first. So if we have $100 compounded 3 times at the rate of 7%, this is the principal. After one compound period, we have the principal plus the interest, and we can simplify this, or we can factorize this, and we get 1.07 times. Now this is the new principal, and this is the new interest, and if we add, we get this. If we simplify, we get this, and this is now the new principal. The new principal plus the interest again we factorize, we get this. So this is the total amount after 3 compounding periods. So this means the formula for compound interest is A for total amount, 1 plus I is the rate of interest per compounding period in decimals, and number of compounding periods, P is the principal. Let's use this compound interest formula for this concept. let's say you have $1 million and you put it in a generous bank that gives 100% annual rate of interest. Annual means yearly, and you put it in a bank for 1 year. If it's compounded annually, so the n is 1 once a year, the interest is 100% per year in one compounding period. So you divide by 1 and you plug in the n and the I. The I is 1 over 1 because 100% is 1 over 1. The n is 1. You get exactly $2 million in 2 years. Biannually means like semesterly, twice a year. The n is 2. The interest per semester is 100%, 1 over 2. So we have the I 1 over 2, the n is 2. Use your calculator, you get this. And if you compound it quarterly, you get this. Monthly, you get this. Daily, you get this. And secondly, you get this value. If you use your calculator, the value of E is this, which is really close to what we have here. So this is the formal definition of the Euler's number E actually. So it is 1 plus 1 over n to the power of n, but this is the limit as n approaches infinity. That's Euler's number. Now to derive the identity rule, this is from the laws of indices. Whatever to the power of 1 is equal to that base, that number. So using the definition of logarithm, log a from here, base a, this is the base, we get 1 of course. And again from the laws of indices we have this. So the inverse is log 1 base a equals 0. Power rule, you can derive this using, let's say, b to the power of n again to the power of x equals this by definition of logarithm. This is log, this is the argument, this is the base, and this is the result. And if we multiply, because power to a power we multiply, we get this, and we can just raise both sides to the power of 1 over m to the power of 1 over m. So on the right we have a only, on the left we have this, and again we use the definition. This means log a base b equals this, or if we just multiply both sides by m over n, they cancel out. And if we multiply by m over n, of course, on the left we have the formula, power rule. Product rule, this is for multiplication. We can just name x equals this, y equals this, use the definition. So m equals log x base a, log y base a. If we multiply, we get this. Of course, we can add the powers. And again, using the definition, the m plus n, which is the result or the exponent, equals the base is a. The argument is from this result here. The quotient rule, similar, but this time we're gonna derive it using the product rule. So using the product rule, if we treat this as if it's a multiplication, x times 1 over y, which is y to the power of minus 1, this is the same as using the product rule. Multiplication becomes addition. And now if we use the power rule, this is minus 1, we bring it down, so minus 1 over 1 from here, so we put the 1 here, minus 1 over 1 times this, we get a subtraction now. Change of base rule, so let's name this m. By definition we get this, and the x is therefore, so if we just raise both sides to the power of 1 over m, we get x equals b to the power of 1 over m, and from here we get x to the equals this. And because x is equal to x, of course, this means a to the power of 1 over m, n equals b to the power of 1 over m. And this means if we raise both sides to the power of m, we get this on the right. And now we use the definition again. This means log b base a equals m over n. And of course the m over n is this divided by this, so it's proven. And the inverse of, actually this is the reciprocal of a logarithm rule. So this is using the change of base rule here. So this is like a fraction. If we use 1 over, we're gonna have to flip this fraction. So simple concept of fractions.